Where did they go? Oh my god.
We are Team Bikely, comprising of myself, Pankuri Sen, and my team member Rajaram. Currently, all the websites that are available in the market do not show any future predictability. This is exactly the problem that we're trying to solve. This is the UI that we have created for our website, which is fairly simple and intuitive. The user can enter the date of their choice, the time during the day, and the station from which they plan to travel. The entering the station is optional. On the map, we can see the availability of a bike. If there are more than 6 bikes available, we see a green dot. Between 3 to 6, there is an orange, and less than 3 is a red dot. On this particular station at Fitbit, we saw that there were only 2 bikes available. Similarly, we can also check the availability of the docking stations. Using the similar information, at the same time, we see Fitbit has about 15 docking stations available, which kind of is intuitive given that there were only 2 bikes available. Another cool feature that we've added is Plan My Travel. The user can enter the date and time on which they've planned to take a trip from the station of their choice to the station of their choice. We predict the amount of time that it's going to take to complete the journey and the availability of a docking station when they arrive there.
To quickly go over the data flow diagram, we're getting a dump of the Ford Go Bike data. There's two essential elements. One is the trips and the other is the station status. The station status is a minute by minute data of about 3 years worth for each of the individual stations. And trips is about 700k, is the details of about 700,000 trips that happen with these bikes. So from the trips data, we parse for station data and we also take trip durations. The station status gives us bike availability and dock availability. We filter and aggregate this data set across like individual station, time of the day, and day of the week. So this entire thing is aggregated and we try to collate and come up with the result. So when we say aggregate, what we did was to consider the mean and standard deviations and put into perspective an operations concept regarding service level. We assume that the demand for bikes is a normal distribution. So we consider mean minus 1 standard deviation to have about 85% accuracy. So the trade-off elements here is between false positive and false negative. We try to keep a fairly consistent standard deviation such that it's evenly distributed. So the technologies used here, data store, we had to use PostgreSQL because of the large volume of data involved. We tried to go the NoSQL way using MongoDB and it just could not handle this level of transactions or we were not doing something right. So in business logic, we use Node.js and Express. Express helped us with the REST APIs, which were helped us build REST APIs, which were consumed by the UI. And for visualizations, we used Google Maps API.
Let's go for a live demo now.